So the screen is visible to everyone.
Yes, sir.
So have you gone through any example of XOR gate as we have discussed yesterday? So where we can use an XOR gate, because the unique truth table applicable to XOR gate is that you will get the output only when one of the input is provided. Otherwise, if there is no input and if there are both the inputs, then the output will be off or zero. So have you came up with any example on the internet? Have you gone through it or not? Yes.
No, sir.
So you should take some time out every time something is given now. So that is just to make this subject more understood and to make it interesting to learn. Because if you are able to uh, recognize the importance of these things and correlate it with the real time examples used in the industry or in any system which you are using in day to day life, then it becomes more interesting to learn. Okay, that is why I have told you to go through such an example which is utilizing XOR gate or uh, NAND gate, NOR gate, any of the gates. Okay, so please do it. Okay, so I hope till the XOR gate it is clear to everyone, or you want to discuss anything
Yes, sir.
again? It's clear now.
Yes, sir.
Okay, the next topic is then the combinational gates or combining of gates. So actually, what we see, if we are designing a digital circuit, then we require various gates which should be connected in series or parallel number of gates, such that you get different type of combinations and different type of results. Okay, so now the question arises that which type of gate should be given on the inputs. So actually what is happening, if you see, if we are drawing a circuit board like this, we can have number of input pins over here, number of outputs over here. This is how a digital circuit works. And in between here, we can have different logic gates. Different logic gates can be installed like this. And these logic gates can have combination to each other or to like this. They can be connected to, and they can have direct supply output also. They can have supply like this also, one supply from this also, one supply maybe from this part also. So that means different combinations. If we see this output over here, this is directly coming from this single logical gate. Whereas this output over here, this is having a combination of these two as well as इसका जो summation होगा उसके बाद you have another summation of this one. So in such a way, you get different combinations. Okay. So the question arises that what should be these gates such that you are able to get various combinations from these gates. Combination means that we can decide for such logical gates that the various combination of those logical gates provide you other logical gates. Okay. So suppose I take number of AND gates, and with number of different combination of AND gate, you are able to get the OR gate also. You are able to get the NAND gate also, you are able to get the NOR gate also, and every gate can be possibly made from those gates. Okay, this is how we decide. And it is seen that if we consider the NOR gate, this is the one gate, one of the gate which will help you get other gates, which will help you get other gates. So you see, this is the symbol for one NAND gate. This is the symbol for another NAND gate. Now, the output of both will give another input to the third NOR gate like this. And Q is the output. तो इसमें हमने क्या किया, दो AND गेट को पहले पैरेलली कनेक्ट किया. After that, individual inputs is given to both the gates such that an output is received over here, and then that output is utilized in the another gate. And you see this particular gate, जो पहला गेट है जहां पे मैंने 1 मार्क किया, उसको it cannot work on a single supply, so it is further connected to two inputs like this. Okay, but these both the inputs have been short circuited in this particular example. So this is another combination which is possible. So you get an output over here, a different output having a different truth table. So you can see the truth table with the intermediate and final output is as follows. जब इसको दोनों को हमने नॉर गेट्स को आपस में कंबाइन करके यहाँ पे थर्ड नॉर गेट पे से पास किया, then what happened, you get an output which is similar to the AND gate, and if we followed this assembly of gates by a NOT gate, then we will get a truth table which is equal to the NAND gate. ठीक है, तो इन अगर आप 3 NOR गेट लोगे, if you consider 3 NOR gates, and combined them in such a form as shown over here, that means the input to the final NOR gate is firstly or is previously passed through the NOR gates only, then the end Q is will be AND gate. And if you put इस AND gate के आगे अगर आप एक, suppose this is the output, and you put an NOT gate in front of it, then the output will be NAND gate. Okay. Similarly, NOR gate, a different combination of NOR gate will also give you an OR gate. It can give an OR gate. NOR gate से OR gate कैसे लगेगा? NOR gate is nothing but OR plus NOT. If you put another NOT in front of this NOR gate, you will get the output as again as OR gate. So you see, NOR gate से आपको OR gate तो मिलेगा ही मिलेगा, NAND and AND gate भी मिल गया. And you can also get XOR gate. For that, we will require more than 3 NOR gates, and this is again your exercise. You have to check on the internet how to get a XOR gate by a combination of various NOR gates. So kindly do that. We will be discussing that tomorrow. Tomorrow is your practice session. We will be discussing the remaining assignments which you haven't discussed. So please, who hasn't been given the presentation in the previous Thursday, they need to give the presentation tomorrow. Okay. So who is available? Agam has given, Prabjot, Rishabh and Vibhor. All of you, you three need to give the still you need to give the presentation. Okay, it is
Okay,
not a
sir.
big task, just small 5 to 10 minutes task individually. Okay, 4 to 5 minutes for presentation and 2-3 minutes for discussion. That is it. Okay, and this is very important exercise, because if you start preparing for presentations from today itself, it will be very beneficial for you. As well as for online classes, we need to see how much you are learning. That is why we have kept a practice session for each of the subject. Okay, so one exercise, that is the pending exercise that you need to follow. All of you need to follow that. That means the assignment one presentation. Plus, for this week, the exercise is you need to identify the application of XOR gate and how to make an XOR gate with combination of various NOR gates. Okay.
Excuse me, sir. Sir, tomorrow is 26th January. So tomorrow would be holiday
No,
or not?
not tomorrow, the day after tomorrow, Thursday.
Okay, sir.
Tomorrow you don't have any class because it is an off day on Thursday. Okay, Thursday on the in the practice session, we will have this discussion on application of XOR gate. So you need not make any presentation for XOR gate. We can just discuss it like that only. Okay.
Okay, sir.
But for the previous remaining part which you haven't completed yet, you need to give the presentations. Okay.
Yes, sir.
So is this part clear to you? The combination of various NOR gates.
Yes, sir.
Okay. So now we see that if we are combining various NOR gates in one or the other form, we are able to get the OR gate, AND gate, NAND gate, XOR gate. Okay, so that is very much possible. Similarly, another combination could be the use of, I need to clear this, combination of NAND gates also. Similarly, the way the NOR gate works, NAND gate also work. NAND is AND plus NOT. So this is the symbol. This is the symbol of AND. Putting a small circle in front gives you a NAND gate. So if you see the NAND gate here, what is happening? The output over here, what it will be? It will be equal to the OR gate. And again, putting a NOT gate in front of it will give you a NOR gate. Okay. And similarly, this is the part that XOR gate. How to obtain an XOR gate from a NAND gate? Kindly go through this also. So three things you have to do: applications of XOR gate, getting a XOR gate from a NOR and a NAND gate. How to use that combination? So kindly look into both the cases. Okay. So if you see that the above illustrations of gate combination show that a NOR or a NAND can substitute the other gates while combining in one or the other form. So these gates can be considered as universal gates. Okay. These gates can be called, the NOR gate and the NAND gate can be called universal gates. So gates can be combined in various complex circuits and sequential circuits. As we have discussed, that their various combination give you various gates and various truth table results. That is why they can be combined in the circuit form to form complex gating system and sequential circuits. This is the actual demonstration of the circuit based on digital system. So it will be called a digital circuit. So digital circuit के अंदर कैसे system काम करता है? So here you see that NAND number of NAND gates are combined at input and output. So there are combinations, like if this is the input over here, this will be the output. This is the input, this is the output. So here input and output may be on the same side or they may be on the other side also. So combination of these gates will give you different results. And similarly, combination of NOR gates, combination of NAND gates. This is how they are actually combined in the circuit. Okay. So clear till this part?
Yes, sir.
Okay. Now we will see some of the applications of logic gates, where these logic gates can be used. One good example that we will be studying, वो आपको मैंने पहले भी काफी बार बता दिया, it is the PLC, programmable logic controller, that we will be seeing in detail, and the programming related to it that we will be seeing, but that part will be covered afterwards. But before that, we can just see some small examples used at large scales, but as they are working on digital systems, so they become very easy to understand and to learn. So first example is digital comparator. So digital comparator means, as the word describes, comparator is for comparison, which compares. So if you want to compare some two digital words or values to determine if they are equal or not, there we use a digital comparator. So such type of combination or such type of protocol can be used in various architectures, various algorithms, where you need to compare two values, okay, such that your output is based on that value. तो आप वो दो values को equate करके you can tell, like for very simple examples also, like if we have made some database according to the marks obtained by students in a given category, है ना? अगर आपने 100 marks का पेपर एक लिया, उसमें आपने you want to store some data and you want the system to be intelligent and determine it on its own whether this what is the category of the student. So you are comparing the values. We are telling it, if the student is getting marks between 80 to 100, then put it in the category of A plus. If it is getting marks above 70 but below 80, then put it in the category of A, and so on. So what we are doing, we are actually comparing the values. So one example is this one. So you can have number of examples in the digital systems also, in the machines also, that while we are suppose utilizing a machine or a conveyor belt to move the objects from the conveyor to the machines, and once number of parts have actually crossed the given threshold value, we want them machine to stop. So what it will do, it will keep on counting it, and when it has reached a desired value of 10, it will stop. Okay, so that there is no congestion or crowd of the objects incoming. We want the already sent items to be processed first. Once the processing has been completed, then only the other set of objects should come. Okay, there we can use a digital comparator. So number of applications for digital comparator. comparison of values, and then taking an output signal or giving an output signal. Okay, so this is done bit by bit. Practically, it is done bit by bit. So for each bit of data stored, as what is a bit? We have already seen that if it microcontroller is there, so it will have a memory where the data is stored bit by bit, and for each bit, the value stored will be compared so that an output is generated. So what is happening over here? What is this gate? This is, or over here, what is the gate? AND gate. And what is this gate? This is an XOR gate.
Plus NOT gate.
Yes. This is not gate.
XOR gate plus NOT gate, because there's a circle after XOR gate.
Yeah. So this is XOR plus NOT. Okay. So here when the values are compared, so one of the signal is sent to the AND gate, and if all the signals would be 1, then only some output would be generated. That means we have designed such a system that if all the outputs are 1 only from the previous gates, then the output at AND gate would be 1. Otherwise, if any of this becomes 0, then the output would be 0. So this is one example where we are using XOR, NOT, and AND gate for a digital comparator. Just a second. Okay. The next is the coder. Coder used for coding or for making some rules and regulations for certain things to happen. Coding is giving some algorithm or designing some algorithm for, or is designing some set of rules for some implementing some processes or letting some things to happen. Okay, so here we have taken a simple example of set of traffic lights which can give red, amber, and green signals with various combinations. So here you see number of AND gates, 3 AND gates are combined with 2 NOT gates. So it is one example. You can have combination in number of ways. So we have decided that red light would be for A and B input as 0. Amber light would be for A input as 0 and B equal to 1. And green light would be for A1, B0. Such simple algorithm we have decided, or set of rules we have decided. So for that, what we have done is before the AND gate, okay, this is how if A and B signal is continuously coming, then NOT gate will make the 1 equal to 0 over here, and for B also it will make it 0. So as this is a AND gate, Q will be 0, but for that 0 we have kept the output as a red signal. If Q become 0, it would be a red signal. Okay. So for amber, what is done? Amber light, A should be 0, B equal to 1. So A should be 0. That means A should be taken after the NOT gate, and B should be taken directly from here. So that means A0, B1, giving the light as an amber light. Okay. Thirdly, A1, B0. You can have another combination also. A1, B1. Another combination can be taken like this. where the signals are directly fed from here, like this signal is directly fed like this signal is directly fed like this. Okay, something like that you can have.
Sir, I have a doubt.
Yes.
Sir, in this circuit, we are always giving A and B high power, like saying we are giving both of them one. But how would we be able to change the light according to time? Like in traffic light, it happens after some time, the light changes. In this circuit, they are glowing together.
No, it is not glowing together. It is the NOT gate which will be activated and deactivated after a certain time period. So what we are doing is we are attaching a clock with the NOT gates. So what
Okay,
the
sir.
NOT gate actually, this is just to show you that how the connections will be there. But actually everything is just passing through it. The lights would be similar. LEDs would be same. Just a second. So practically what will be happening, only consider this part only, where the red light is blinking. Just forget this, forget this, forget this, forget this. Forget everything. So you just see that the circuit is directly connected like this only. Okay.
Yes, sir.
So for now, for getting the red light, these both NOT gates would be activated. We have activated these both the NOT gates which are connected to a clock. And after a certain time period, if we want the amber light to glow for a small, very small time period, what we will do is we will deactivate the NOT gate present over here at B, so that B becomes 1 and A becomes 0. So, okay, instantly the light will change to amber. And after some time, what will happen? This gate will turn off, and this will turn on. You will get a green light. Similarly, if both will be turned off, you will get another light, maybe some other color light you can get. So you can glow the LEDs to various colors using these combinations. This is what is actually happening. Okay, you have a direct circuit only. Here you are just turning on and off the NOT gate after a certain time period. So NOT gate को activate करने का क्या तरीका है कि उसको करंट की सप्लाई देनी है नहीं देनी है. If you will turn off the supply to the NOT gate, it will turn off. If you give the supply to the NOT gate, it will turn on. So that will be decided by the clock. So clock will have a switch inside which will connect and disconnect the circuit after a given time period. Okay, that is what is happening. And clocks can work on various techniques. They can be electromagnetic, they can be mechanical, such that they keep on clicking, and after certain time they engage and disengage the circuit. So such type of mechanical system can also be used in your electronic system. A memory can be installed with the clock. Memory will store the time period for the clock to activate and deactivate. Okay, so this is how it works. I hope it is clear to you.
Yes, sir.
Okay, any doubt with anyone else? Okay, no doubt. Vibhor, you were present yesterday for some time, then you left the class. What was the problem? Vibhor?
सर कहीं जाना पड़ गया था एकदम से, इस वजह से.
Okay. So whenever such thing happens, kindly drop a message in the chat box only. Okay, that
Okay,
I need to go somewhere, and that is why I've left the class. Okay.
ओके सर.
Okay. Then next is the sequential logic. Sequential logic is again the same sequence or sequential control system which we have seen in the case of control systems also. Okay, so for digital control systems also the same sequential logic is applicable. Okay, number of what happens in a sequential control system, that the output from the first stage is the input to the next stage. This is how it works. So simply, as we have seen in the example of NOR gate and NAND gate, that is also example of sequential control, that firstly two NOR gates are connected in parallel, and the output from the both give the input to the third NOR gate. That is also sequential control. So one thing to notice over here and to learn and to remember, that it will always have a memory. The sequential control system will definitely have a memory, to some or the other form of memory would be there to store the combinational logic. When to trigger which combination. So there should be a memory to store that data. Okay. Everything else is same, just the combination of various gates. So external inputs, combinational logic gates give you output, and some input is also coming from the memory side. And whatever is happening in this combination logic gate is stored in the memory. So memory is connected as an input also and as an output from the logical gates. Next is the flip-flop system or set and reset system. So commonly used flip-flop system are also called SR flip-flop, that is set and reset type of flip-flops. Okay. So this is the one example which, so over here it is written SNR. That means setting a value, setting up a value that will give a output as Q, and if you reset it, it will give an output as Q bar, that is Q naught, or Q modulus, which is, what is Q modulus? Q with the NOT gate. That means opposite of Q, inverse of Q. This is Q inverse. So if you set a value, set the button, it will keep on running. And if you reset only, then it will come to an halt. So you must have seen such type of system. Then for this particular machine, there is one switch for setting and one switch for resetting. Okay. In computers also, in CPU, if you have must have seen that in desktops also. Previously, there used to be two separate switches for setting and resetting. If you press this push button, it will start the machine. And if you again press it, it will not turn off the machine. But for turning off the machine, you have to press this reset button. Then only this machine will be coming to an halt. So the such type of flip-flops are very much used in number of machines. For a simple CNC machine also, or for a hydraulic power hydraulics press machine. So number of machines, if you see the switches, they are having two separate switches. Okay. So that is basically used for avoiding any accidental or any not a, you cannot say the accident as such, but because what happens when the machine starts, it takes up large amount of power for starting. So the circuit can break if you use a single switch for setting and resetting. That is why two separate switches, because the power required for starting is very much large as compared to the power required for resetting it. So the type of resistance which is present with the set button, suppose over here, and for the reset button, it may differ. And this will be helpful for some circuit breaking in the case of power failure. That is why we use the type of switches or power box which is used for machines consuming large amount of power in the industry, require boxes or power units which will have a separate start and stop button. That is the reason. Okay, so here these flip-flop type of set reset buttons are used. So what has happened if you press the start button, it will start the machine, and if you will again press the start button, nothing will happen. The machine will keep on running. Okay, so it has just given a large amount of power for starting, and now it is free. It is giving no response. It has broken the circuit between both, so to avoid any power failure or to avoid any short circuiting. But once a reset button is pressed or stop button is pressed, then only this spring operated suppose switch will come back and start button will be activated. तो कहने का मतलब है जब आप स्टार्ट बटन को चाहे 10 बार दबा लो, एक बार स्टार्ट करने के बाद उस nothing will happen until the stop button is pressed. So mechanically what is happening with the stop button, there is some cam or some you can say some bracket type of system is there, और एक प्लेट होगी अंदर उसके, जिसको प्रेस करते ही ये इसके स्विच को it will move backward, it will trigger it. Otherwise if you will keep on again and again pressing it, nothing will happen. So such type of system is called set reset type of buttons. उसको सिंपली याद रखेंगे कि सेट रीसेट में क्या होता है, आपने जब सेट बटन दबा दिया, the output will start, and again if you are turning off the set button, nothing will happen to the output. आपने एक बार सेट बटन दबा दिया एस बटन को, तो आपके पास you start getting Q as the output. ठीक है, अब सेट पे हमने क्या वैल्यू दी 1, तो Q पे भी कितनी मिलेगी 1. अब आप चाहे सेट को फिर से 0 भी कर दो ना, दोबारा भी दबा दो, तब भी Q पे आपको क्या मिलती रहेगी वैल्यू 1. तो सेट की 1 वैल्यू इसको Q की 1 वैल्यू देने में एक बार इट विल हेल्प. देन इफ यू अगेन सेट इट टू 0, दैट मींस आपने अगेन उसको ऑफ भी कर दिया सेट को, तो भी आपको Q पे 1 मिलती रहेगी. तो Q पे 0 करने के लिए क्या करना पड़ेगा, हमें रीसेट को 1 देना पड़ेगा. रीसेट को 1 देते ही Q डैश 1 हो जाएगा. दैट मींस Q1 डैश होने का मतलब क्या हो गया, Q 0 हो गया. ठीक है, अब आप रीसेट को भी अगर दोबारा से 0 कर दोगे, तो व्हाट विल हैपन, नथिंग विल हैपन. दिस कंडीशन स्टिल रिमेन्स. अब इस कंडीशन को चेंज करने के लिए क्या करना पड़ेगा, दोबारा से सेट को 1 करना पड़ेगा. ठीक है, अब एक बार सेट को 1 कर दिया, Q 1 हो गया, Q डैश 0 हो गया. अब चाहे सेट को जितनी मर्जी बार दबाते रहो, कुछ नहीं होगा जब तक आप रीसेट को नहीं दबाएंगे. Once you press the reset, only then this state will change. Now, once the state is changed, then again you have to press the set button. So this cycle keeps on going. That once reset will work, set will work for only one time until reset is pressed, and reset will also work for one time until set is pressed. So this is a very important circuit which is used in mostly all the machine combinations. So here you see that firstly we will see the its circuit diagram or its symbol. So this is, what are these two gates? What are the gates over here? Yes, can you tell?
NOR gates.
NOR gates. So two NOR gates are there, having one value directly passing through it and other value is actually connected to the output over here. Okay. So this is the reset button. For set button, one input is over here and another input is from the output of the one. So what is happening if you have given, so if you draw the truth table of NOR gate, what is the truth table of NOR gate? A, B and Q. If A is 0, both are 0, this is 0, this is 1, this is 1, this is 0, this is, both are 1. For 0, 0, how, what is the value of Q? For NOR gate, it is the reverse of OR gate. 0, 0 is 1.
1.
0, 1 is
0.
0, 0.
Yes, sir.
Okay. So you are getting output from this when both are 0. Both are 0. So that means when the machine is off, or you can see at the reset position, Q is 0. Q is 0. So Q0 is coming to this side. And if you press this button, आपने इसको जब press कर दिया, then what happens? Initially, it was 0. When it was not pressed, it was 0. So if both were 0, you were getting Q0 not as 1. That means Q dash was activated. Is it clear? When Q dash was activated, you were getting value 1 over here and 1 over here, because you have, at that point, you have pressed the, yes, you have pressed the reset button. So for 1, 1, the combination was coming out to be 0. तो इसको चेंज करने के लिए, Q को 1 करने के लिए and Q नॉट को 0 करने के लिए, what we have done is we have given Q0 is 0, we will change it to 1. The instance we change it to 1, that means we have pressed the set button. So Q से 0 आ रही है वैल्यू, यहाँ से 1 आ रही है, तो 1 और 0 के लिए यहाँ पे 0 हो जाएगी वैल्यू. So this will become 0. So the moment it becomes 0, then what is happening? Now the reset button is changed to 0. This becomes 0, this becomes 0, so Q becomes 1. Okay. अब जब आपका Q 1 बन गया है, so what will happen? यहाँ पे भी 1 है, यहाँ पे भी 1 है, तो ये कितना रहेगा? 0 रहेगा. अब आप इसको चाहे 1 से 0 भी कर दो, बट क्योंकि Q अभी भी 1 है, तो यहाँ पे still it will be 0. समझ आ गई बात? इसको 0 करने के लिए हमें Q को भी 0 करना पड़ेगा. That means we have to again press the reset button. The moment reset button is pressed, that means what will happen? the Q dash over here is 0, and if this becomes 1, then this will become 0. Once it becomes 0 and this is already 0, this will become 1. This is how it works. So are you able to understand it?
Yes, sir.
So employing two NOR gates makes it possible, but we have to give the one of the input from the output. That is why it is a sequential control type of system also. So here you can see in the circuit diagram, when I have started the set button, जैसे मैंने set button को start किया, मेरी output start हो गई, उसके बाद मैंने set button को off भी कर दिया, पर फिर still I have the output going on, it is not affecting it. But the minute I press the reset button, it has turned off the supply queue. ठीक है, और वो जब मैंने फिर रीसेट बटन को ऑफ भी कर दिया तो अभी वो ऑफ ही रहेगी जब तक इसको मैं दोबारा से ऑन नहीं करता, फिर यहां से ये ऑन हो जाएगी. सो नो चेंज इन पोजीशन. पहली बार जैसे ट्रिगर करने पे इसकी पोजीशन चेंज होगी, उसके बाद आप इसको जहां जब मर्जी चेंज करते रहो, नो, इट विल हैव नो इफेक्ट ऑन द आउटपुट. So the flip-flop system is understood?
Yes, sir.
Okay. So I think the time is over. So we are just left with the register parts. So register is another type of, you can say, flip-flop system used for storing of data for a given time period. So here D type of flip-flop systems are used. So D, अभी SR flip-flop पढ़ा था हमने, D होता है delay flip-flop, which can delay the value for some time. So registers कहाँ पे use होते हैं? जहाँ पे आपको एक इनपुट दिया आपने, पर वो इनपुट आउटपुट पे कुछ टाइम के बाद आई. So there is a delay in the input to reach the output. Okay, there we will use a delay type of flip-flop, and this system is called a register. And a clock, CK is the clock. Clock is used with the register, which will clock the value for certain time period. So here you see that for various clocks, we are getting the clock and memory as an AND gate associated with it, which is connected over here, and different inputs for various registers. So ये इसमें हमारा 4-bit system है, तो हर बिट के लिए अलग हमने एक फ्लिप फ्लॉप सिस्टम लगाया हुआ है रजिस्टर में, ठीक है, जिसमें 4 डिफरेंट आउटपुट मिल रही है हमें. So simply you have to, it is simply working the same way the flip-flop system works. The difference is you now have a clock associated with it, and a delay type of register is used, which will give the output after a certain time period. Okay, this is how it works. So register is a set of memory elements used to hold information until it is needed. That means input will be stored for a certain time period. So it can be implemented using delay flip-flops. So it stores value 0 और बस वही है 4-bit के लिए different 4 register use होंगे. They will store the memory. Just we have a combination of clock, which is connected directly to the delay flip-flop and turn on and off the flip-flop after a given time period. So that is it in this chapter. So we can discuss the queries in the next class, and you can just come up with the part which we have discussed, है ना, the XOR gate के combination में उसके example, और उसको NAND and NOR gate से combination से कैसे वो बनता है, वो that we can discuss in the class on Thursday. So tomorrow is off. So any questions?
No, sir.
Okay then. Thank you very much. Just a second. Okay, thank you.